Hello, everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 6A. Myself is Shita Soran, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 28th of February 2024, and the virtual event is being held through Zoom today, and it was held tomorrow, that is 21st and 22nd February 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we'll have 6 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for question and answers. On 10 minutes, I will raise a general reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to the chair for this session. We have with us our session chair, Dr. Sachin Gupta. Welcome, sir.
Hi, Ishita. How are you?
I'm doing well, sir. Thank you.
Okay. All the very best to everyone who is presenting the conference today. And I look forward to learning from the session. As a researcher, this is more like every conference is a learning opportunity, and I hope everyone does good. Thank you so much for having me.
Thank you, sir. We have our second session chair, Dr. Narmal Shuaman. We welcome you, ma'am. Ma'am, your voice isn't audible. There seems to be an issue with the audio, I guess. We can't really hear you. Maybe the audio isn't connected. I feel like that. By the time map connects with the audio, we'll be proceeding with our paper presenters. I'd like to invite our first paper presenter for the session, Sir Mohammed, with the paper titled A 3D Virtual Laboratory for Computer Hardware Classes. So if you're here, then you can start your presentation.
Hello. Yes, I'm here.
Yeah.
Yeah, our co-author will be presenting, Andre.
Okay. No issue.
Andre, can you please share the screen?
Yes. I will share. Okay. Can you see my screen now?
Yes, it is visible. Please go ahead.
Yes. Okay. This is the structure of the paper. And in the introduction, the era of the internet and the information technology was profoundly transformed the way we learn. And virtual laboratories are believed to have significant potential to offer efficient and cost-effective solution for practical lab works compared to traditional labs. So therefore, the current research focus on the design and development of a 3D virtual laboratory for computer hardware classes aiming to provide solution to the problem of lack of physical equipment for conducting practical IT laboratory activities. So the related works used in this research were the Fugate as Damasceno et al. That developed a SimNet 3D software simulator for virtual network experiments for enhancing content acquisition and reducing implementation costs while maintaining physical laboratory and boosting students' motivation. And Lobo, Morphosa, and Dube explored virtual reality education, creating a 3D simulation of a chemistry laboratory in response to the COVID-19 pandemic. So about the design and development of the simulator. Blender, Sculptris, and ZBrush was used for modeling, and the Unity game engine for programming, aiming for an interactive learning experience for the students. And about the functional requirements, the first one was the system must allow the users to answer quiz about the computer defects, and the users must be able to choose between returning to the game or going to the main menu after losing a quiz. And the third one, the system must display the score and classify the user according to the points obtained up to a maximum of 100 points. The system must allow the user to move the avatar freely while exploring the laboratory. And the system must allow the user to switch between first and third person view cameras. The user must be able to perform computer maintenance, and the system must allow user to read tutorial about the game, and system must allow the user to view object in details too. And inside of design and development, the non-functional requirements include the system must be developed using the Unity 3D development environment, and development in the C# language, and for web platform using WebGL, and
Excuse
the
me, sir?
system must set a time limit of.
I'm really sorry to
Sorry?
disturb you, but the slides aren't changing. The slides of your PPT.
Okay. Can you see the slide?
You
No,
can see them.
only the
No.
title
You
slide.
have
is-
they are static on the slide one.
Yeah.
Okay.
André, o slide não está a andar, está parado na capa.
Não está,
Yeah,
não está a andar.
a andar, sim.
So- And
Maybe
now,
you can, share your screen once again. I think it seems to have stuck.
okay. Let me stop the share of the screen and start it again.
Yeah, sure.
And now,
Yeah, certainly. Perfect. Please go ahead.
okay. So continue. Inside of design and development, non-functional requirements include the system must be developed using the Unity 3D development environment, and the development using the C# language for web platform using WebGL. And the system must set a time limit of 30 seconds for quiz responses, and must have a background music. And the players can be classified into different categories according to their points, and the grade is assigned to the student using a formula to convert points into grades using C# code. And this is the formula used in the C# code to convert points obtained into grades. It's a point divided by 100 times 20. And this is the conditions using to classify. If the grade is less than 10, the student is considered beginner. And if the grade is greater or equal 10, it's intermediate. And if a grade is greater or equal 17, it's advanced. And if grade equal 20, it's a professional. And so now about the development and results. The software development lifecycle model used was a prototype. And the development of the 3D laboratory prototype involved stages such as modeling, material application, testing, animation creation, and logic programming. About the conclusion and recommendation, the article describes the development of a 3D virtual laboratory for computer hardware education at the College of Engineering, providing an engaging learning experience. And the player's classification system and offers a feedback at student for a student performance. And the development involved various stages ensure fidelity to the real components. And this is the reference, use it in the slide and in the paper. And thank you for your attention. So let me now show you the screen of the I will change now the screen to share the screen of the simulator. The screen of the simulator. So can you see the screen now?
Yes, please.
Yes.
Okay, let's go ahead. This is the virtual laboratory for hardware classes, and it includes these three options. And in the first option, we have this the screen that have these three buttons. And the red button is for erase punctuations, and the play button is the main button to go to the different topics it offer for the students. And the first topic have some quizzes for the students. And the language now is it in Portuguese because it's in a Portuguese speaking country. And the student have this problem that is showed as a question and have some options to give the correct answer, and the time is running up. If student give a right option to the question, he in some points, in this case 10 points, and the time is restarted, counting down 30 seconds again, and student must give another answer. And if the student give a wrong answer, he is redirected to the screen that he can see his punctuation. The student have, in this case, 20 points that is converted using the formula to the grade. Assign it now, it's only 4 grades with the 20 points. And the student can return the screens and go to another laboratories options. In the laboratory number 2, the students have this section. This is a practical section that he have a motherboard and his components, and have some buttons to see here. He can use this help button to see some informations. And he can now choose different cams using the information in the help section, these different camera views, and choose the component he need to know, and see how to work button. And in this how to work button, he is redirected to the component room, and use this room to see how to work with the component. He can use these buttons to using this tutorial and view how to use the CPU socket and the CPU, how it works. So it can offer the student a practical experience in the virtual lab. And if the student use a wrong order of the socket, it
Excuse me, sir.
shows error miss message. Sorry.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Okay.
Yeah.
Yes. So this is this is all for now. I passed the I will finish it. I will finish it now. So this was all for the presentation, and I give you the section control.
Thank you for your presentation. Did you see any difference between the student attention span when they were working without this, or why could we not bring it in the lab itself instead of making it virtual? Because the components are easy that can be brought to the lab itself. Why simulate them in 3D?
Sorry, I didn't understand very well. If you can repeat, please.
Okay, my question is that the computer hardware components are easily available. You would be finding them in the laboratory. You can bring them to the classroom. What was the motivation for simulating this?
Yes, the computer have much more components, and the laboratory have some subdivisions, rooms, and in that room there is only components of the motherboards, and there is another rooms which other components of the computers that users can access.
If I may help him answer this question. This lab was designed because in Mozambique, especially our university, UCM, we don't have a physical computer lab because of financial reasons. So that's the motivation. And also because of the COVID situation, we could teach the students from far, remotely, how to work with computers and hardware and all. Thank you.
Got it, got it. Thank you so much.
Thank you for your presentation, and it is an interesting application. And I have one question. Who has tried your application? Who? Who had tried?
So, Mr. Mohammed, can you help me, please?
Yeah, sorry, I couldn't hear. I do. It wasn't clear. Yeah, could you please repeat? Dr. Narmo? Yes, could you repeat the question, please? I couldn't hear what you said.
Oh, okay. My
Yeah.
question is, who had hired this application? Who?
Who had the hired?
Yeah, yeah, yeah.
Okay. Hired the application how? To make the lab. Okay. Yeah, I'm a professor. He's the bachelor degree student. So yeah, I'm running a project here at our university, and he's one of the best students. So I hired also a part of my thesis that I'm working. Yeah, so I had him to work with me, and he showed really excellence in this area, and he was really motivated. He wanted to work in something. So yeah, that's how we are here.
Okay, thank you.
Yeah. And,
Thank you, ma'am. Thank you, sir. We'll be proceeding with our next presenter. I'd like to invite paper presenter Azunka with the paper titled A Novel Single Band Antenna for Enhanced V2X Communication, Review Towards Prototype Development. So you may start with the presentation. So Azunka, if you're here.
Yes, can you hear me?
Yeah. You're audible.
Okay, sorry. Let me try and get my video working and share my screen. Good morning, everyone. Okay, sorry. Can you see the full presentation? Hello?
Not yet, sir. Your screen isn't visible yet. You haven't started your screen sharing yet, it seems.
Oh, I have. Sorry, just give me 1 second again. Sorry, can you see my screen now?
Yes, sir, it is visible.
Perfect, perfect. Okay. Good morning, everyone. Our work is basically a novel single band antenna for enhanced V2X communication. This was work done towards review, towards building of a prototype. Let me just get that's better. Okay, so the first slide just basically goes through the structure of what I'm going to present to you all today. Looking at the background and mission statement, I then consider the literature review again, sticking with the background, look at the research objectives, antenna design, literature review and the gap identified, as well as the detailed antenna design and limitations. I then go through a quick depiction of the results that we achieved, as well as conclusion and future work and closing remarks. And at that point, I'll be happy to take any questions that you have. So generally speaking, we've looked into this work because of the current move towards obviously smart living and the idea that most of the things are getting built to be smart enabled. You know, we have driverless cars coming soon. We have urban areas which would need to work, you know, traffic light system, and it's basically just driving forwards innovation towards the smart environment which we are heading towards. Then we look at the design objectives. The key areas that we were looking at was enhancing the bandwidth, increasing the gain with the design that we're proposing, and compactness, because of course, as far as antennas go, you can get any antenna, but not all of them are compact. And if it's not compact, then we end up with a very crowded environment for the sake of, you know, being able to communicate freely and efficiently. Now, the depiction on the right kind of shows what I just explained, which is that, look, we do need antennas to function. They, you know, they do a lot in the current world that we live in, and certainly towards the direction that we are going with smart living, they'll continue to do more. And if we had to rely on, you know, the typical antenna design, then we would essentially end up with a environment looking like what's been depicted on the right there, where you have, you know, really no clear skies because you're trying to transmit data, or you're trying to transmit information through radio waves. Some of the gaps highlighted were the ones to do with the bandwidth and frequency specificity. We got signal clarity, which was part of my thesis, actually, signal clarity and reliability. We got the compactness and integration, which is where the patch antennas really come in handy. Then we got high mobility for performance, which essentially drives to the fact that once the antenna is built, they can effectively be integrated into almost anything. We got cost effectiveness. I mean that in the whole sense of both cost effectiveness for manufacturing and cost effectiveness towards research and design. And then we've got the regulatory and spectrum efficiency as well to consider. This kind of goes through some of the design at the early stages. What we've got on the left is the initial design showing all the parameters and the sizes that we've used for the 3.4. And then on the right, we've got the proposed antenna design, which has been put through the simulation system. Simulation results, we've shown the magnitude to see that it performed well and in line with what we were expecting it to be. And as you can see there, it peaks right at the 3.4, which means that our calculations were as good as we could get it. We've got the gain. It doesn't quite peak where we needed it to peak, but it's close enough. So it's a decent result, decent outcome. We've got the antenna efficiency, which also shows a good result, and then we've got the directivity, which also shows a half decent result. Now we've put down as part of the limitation at the facilities at the University of Hertfordshire, we don't have an anechoic chamber, and we don't really have an environment where we would have been able to test this physically. So we've kind of put that down to part of the limitations of this work. Going further, to conclude, essentially, in the current domain that we're heading towards, i.e. the intelligent transport system, what we are proposing goes a long way towards redefining a single band antenna, which will be crucial for V2V and V2R communications. Part of the reason we've gone for the 3.4 is based on proven propagation advantages, especially for vehicular use. And we've shown with the results that we achieved that the antenna works both gives a superior performance to your standard antenna, and it's got a quite decent gain, and the signal strength is also good, which goes in line with what we were able to achieve from the ADS design parameters when we tested it, that is. Thank you very much for listening. I will take any questions that you have at this stage.
Thank you for presentation. I'm not in a field of antenna technology, but this prototype used for digital or analog signal.
For digital.
Okay.
Dr. Sachin, would you like to ask any question? There could be a connectivity issue, I guess. We'll be proceeding on with the next presenter. Thank you, sir.
Thank you.
We have our next presenter, Eneko Osaba, with the paper titled A Quantum Computing-Based System for Portfolio Optimization Using Future Asset Values and Automatic Reduction of the Investment Universe. So if you're here, then you can start with your presentation.
Can you hear me?
Yeah, we can hear you. You're audible.
Okay, so I will try to share my screen.
Sure.
Okay. Sorry. Okay. Vale. Here. Okay, I'm doing so. Okay. Please tell me if you can see
Yeah, sir,
the
it is visible.
slides.
It is visible. Please go ahead.
What?
It is visible.
Yes. Okay. Okay, it's okay. So I'm going to present our work, which is called a quantum computing-based system for portfolio optimization using future assets, values, and automatic reduction of the investment universe. So the first thing that I need to say is that which is the context of this paper, which is the quantum computing. Today, quantum computing is considered probably as the next frontier in computation, and it is attracting a lot of attention from the related community. There are a lot of papers and a lot of projects that are now focused in quantum computing. In overall, there are two kinds of quantum computers. The first ones that are based on a gate model, which is the one that we can see in this slide, this figure. This is the quantum computer of IBM. And the other one is the annealing-based quantum computer. In this second slide, we can see one example of a quantum annealer of the D-Wave company. Today, quantum computing is quite interesting for researchers and practitioners because it provides an alternative for addressing optimization problems. So anyway, despite that there are a lot of papers, a lot of projects, as I say, a lot of funding from the European Committee, for example, the thing is that today quantum computing is in an incipient stage of development. So the current computers present a lot of limitations in their capability and even in their results. So the thing is that there are two kind of different paradigms. This paper is focused in quantum annealers, the quantum annealer of the wave. So today, quantum computing has been employed to solve different kind of optimization problems. For example, the problems such as the bin packing problem, or the jobs of scheduling problem, or the vehicle routing problem, or the portfolio optimization problem, problems related with financial issues. And in fact, this is the problem that we have dealt in our paper. So the paper that we have presented aims to describe and to present a quantum computing based system for solving the portfolio optimization problem. So we have called our system, as you can see in the slide, but Q for future pop. We are going to call us Q for future pop. So the main innovations of our system is that it can work with future projected values, and probably the most important future innovation is this automatic universe reduction, which is here to solve the problems in a more efficient way. The thing that I have talked about, that today quantum computers present some limitations. Okay, so these limitations is that they cannot deal with very big problems. So with this automatic universe reduction system or mechanisms, we can reduce the complexity of the problem in order the computer solve it in a more robust way and obtaining better results. So talking about the formulation of the problem, we have used the well-known Markovitch formulation, which aims to maximize. We have a set or a group of assets in which we can invest a certain amount of budget. So the objective is to maximize the return of this portfolio, minimize the risk associated to this portfolio, and not exceeding the budget that we have allocated, and also the quality of each portfolio could be measured on the return, the expected return, also the risk, or in the Sharpe ratio, which is the division, the relation among these two parameters, the benefit and the risk. So how the data is introduced? The data is introduced in the system in this way that I'm showing in this slide. So we have all the prices every day for all the assets that we have. For example, if we contemplated 40 assets and 1 year of time horizon, we need to have a file with all the prices of these assets along all the years that contemplate the problem. So how we can codify the problem? Okay, because today quantum computers just work with binary variables. So to each asset, we dedicate, in this case, 5 different bits. In this case, 5 different qubits. The thing is that depending on the value of this qubit, 1 or 0, this is going to determine how much of the budget is assigned to each of the assets that we have in our portfolio. So this is the workflow of our system. It's divided in 3 different modules. The predicted dataset generation module, which is devoted to generating these predicted values of the assets. The asset universe reduction module, which is in charge of intelligently reducing the complexity of the problem. The quantum computing solver module, which is the module that solves the problem, provide the results. But because this paper is focused in quantum computing, so I'm going to focus in the last two modules. So I'm going to start with the last one, because the assets universe reduction module also uses quantum computing solver module. So I'm going to talk about the quantum computing solver module, which is also divided in three different sub modules. The first one is the Cubo builder, because the quantum computers just solve problems in a specific format. So the first task to work with this quantum computer is to take the problem, the formulation of the problem, the input data, and to model the problem as a cubo. Then the quantum annealing solver. So once we have the formulation of the problem, we solve it using the quantum computer, and then the results interpreted. Why? Because the problem is a binary problem. So the quantum computer provides us an array of binary values. So we need to traduce this result in a more legible solution in order to is the readability of the solution. So this is the module of the quantum computing solver module. The other one is the assets universe reduction module, which is an iterative process in which first we preliminarily solve the problem some predefined times, 3-4 times, and we just store the IDs of these assets that the computer has shown that they are promising. Then, using this subgroup of assets, we reduce the problem just to these defined assets, and we solve finally the problem in order to provide the final result to the user. So how we accede quantum computer? We accede using the LEAP platform of the Wave. The computer that we accessed using through this research is the Advantage System 6.1. And now I'm going to talk about some results. So I'm going to show two different tests. For this test, we have some portfolios provided by an expert enterprise called Wealthia, and they provide the portfolios and the assignment return and risk. So then we have run the quantum computer, our system, and we compare our results with those provided by the experts. Here we can see that the different kind of executions. We can see that the quantum computer, in fact, works better than the experts in terms of results, and providing more risk by comparing with the experts' results. These conclusions are also replicable in this second test. Better returns with similar risks, and we have here a resume of the test that we have provided in the paper. Anyway, despite the quantum computer, this system is better than the experts. This does not mean that we need to take a triumphalist conclusions, because the reality is different from this academic solution. The thing is that today in the literature, a lot of people, and also us, measure the results in terms of risk, in benefit, and Sharpe ratio. But the thing is that in the reality, there are some additional things that must be taken into account. In any case, this system that we have developed, it has been appreciated by the experts, by Wealthia, and they have considered that this kind of systems can be a good tool for their day-to-day operation and to take as a decision-making helper. As future work, we are going to test the complete system and also work with additional data sets and portfolios. And this is the last slide on my presentation. If you have any question, thank you so much for your attention.
It's a very interesting presentation. I just had a query out of curiosity. like machine learning problems can be generalized to different optimization problems. Do quantum algorithms also generalize the same way, or would it be specific to the data that we are using?
The thing is that I am not expert in machine learning, but in fact there is one stream in this quantum computing world that is quantum quantum machine learning. There are some different kind of quantum algorithms, such as quantum neural networks and this kind of solvers that, of course, I think that they can help to solve the problem that you are talking. But I say I am not expert in machine learning, so I have not worked in quantum machine learning.
Thank you so much for the insight.
Thank you, sir. Ma'am, Narmal, would you like to ask any question? Ma'am Narmal?
Okay, I have one question. This is a good work. I want to know what the limitation of your work.
The motivation of our work. Yes, no, yes, the thing is today quantum computing is in a very incipient stage of development. So the thing is that today there are some works that are just proof of concepts, just to preliminarily analyze how quantum computing can behave with this kind of solver. So the main motivation of this research is just to make a proof of concept about how can quantum computers help to the experts in this area in their day-to-day operations. So this is the main motivation of our work.
Okay, thank you.
Thank you.
Great work, congratulations.
Thank you.
Thank you, sir. We will be proceeding with the next presenter. I'd like to invite a paper presenter. Divide Human with the paper title CCMT, a code complexity measuring tool. So if you're here, then you can start your presentation. Yeah.
So can you see my screen?
Yes, sir, it is visible. Please go ahead.
Yeah. So hello everyone. So I'm Yasite, and thank you for giving me this opportunity. So today I'm going to talk about CCMT, a code complexity measuring tool, which is basically a tool to measure the complexity of a code based on 9 factors. So moving on to the agenda, here I will be covering these topics, which are introduction, where I'll be talking about the limitations and the challenges of the current software industry and a need for a tool to measure the complexity and the cognitive code complexity measure, which is our tool, the methodology, the technology stack we have used to develop it, the proposed system, the results, the discussion where we're talking about the limitations of a current metric and how our metric could overcome those limitations, and finally the conclusion. So starting off with the introduction, so the current challenges in the software industry. So there's a growing demand for dependable software, increasing inherent complexities in software program are some of the challenges. So since the software industry or the domain gets updated and expanded day by day, so there is a need for a tool to measure and analyze the complexity of a code. And also the limitations, as I said, the inconsistency and unreliable measurements in current models, and also need a structured tool to scrutinize the source code. So these are some existing limitations and challenges in the software industry. So we came up with a tool which is CCMT, code complexity measuring tool, which comes from the cognitive code complexity measure, which is our metric, where we consider these 9 factors, which are size, type of control structures, nesting level of control structures, inheritance level of statements, try-catch blocks, recursive calls, array declaration, compound conditional statements, and input-output statements. So first, I'll be discussing the first four factors. So size. So here we measure the complexity by measuring the length of each call by assigning token-based system. Then WC, which is type of control structure. Here, what happens is we measure complexity. We basically assign a weight of 1 for sequential codes like array declaration, variable declaration, and if there is an if a statement, we assign a weight of 2, and also if there is any iterative statements like for loop or do while, we assign a weight of 3, and also in switch case statements we assign weights based on the number of cases. And the nesting level of control structure, which goes along with type of control structures. Here, we assign a weight of 1 for the topmost control structure and a weight of 2 to the second most control structure. And the inheritance level of statements, it's by default 1, the weight is 1, since everything comes under the object class. And if there is any child class or an inherited class, we assign a weight of 2. And the next few array declaration, try-catch blocks, compound conditional statements, and recursive calls I'll be discussing in the next few slides. So coming on to the recursive calls, which is WRC. Here what basically happens is we assign a weight of 1 for the initial recursive call and increment it by 2 for each additional recursive call. So in this code segment, you can see the Fibonacci n-1, the initial recursive call, we assign a weight of 1. And the additional recursive call, which is Fibonacci n-2, we assign a weight of 2, which gives us the WRC value as 3. And the compound conditional statements, here we consider about the and O operator. So in this code segment, there are 2 and operators and 1 operator. So we assign a weight of 1 for each, 1 for AND operator, which is sunny and has free time, and 1 for the O operator, as well as the 1 for the last and condition, which is raining and has umbrella. So which gives us the WRC value as 3. And moving on to the try catch. So here we assign a weight of 1 for try keyword and 1 for catch keyword. And if there is any nested level of statement, we assign a weight of 2. But in this code segment, there's no such case. We have only one try catch block. So we assign a weight of 1 for try and 1 for catch keyword. So which gives us the WTC value as 2. And lastly, the array declaration, here we have come up with an equation which is WAD equals WA into SAD, where WA is the dimension of the array, which is basically a 1D or 2D array likewise, and SAD is the size of the array. So as you can see in the sample code, the first one is a 1D array. So what happens here, we multiply 1 by the size of the array, which is 5, which gives us the WAD value as 5. And the next is a 2D array with the size of 6 and 4. So we take the sum of the sizes of the array and multiply it by 2, which gives us the WAD value as 20. And this is the equation for our CCC measure. So CC is the cognitive complexity of a program. M is the total number of executable code statements. SK is the size of code statement. And W1 is the sum of WC, Wn, and Wi values, which are control structures, nesting levels, and inheritance level of statements. And W2 is the sum of recursion, try-catch, compound conditional statements, array declaration, along with input-output statements. And the proposed system, which is our CCMT tool, so it computes complexity based on the CCC measure, where we consider 9 factors. Has a user-friendly interface, provide more comprehensive understanding of code complexity, which allows the developers to structure their code to help them easily understand the code by lowering the complexity, which also enhancing software quality and making informed decisions, and also improve software development process as well. And moving on to the methodology. And so here the technology stack we have used is we have used IntelliJ IDE as the IDE. We have used Spring Framework, where we have used Java as the backend. We have used MySQL, Antler, React.js, JavaScript as the front end. And also we have used the regex software component, where normally it is used to identify certain strings, characters, likewise. So for example, during measuring try-catch complexity, so we have used regex to identify the try and catch keyword. And also in compound conditional statements to identify the and operator, we have used reject components. And so moving on to the result section. So this is typically a result sections how we have measured the complexity of this code based on these 9 factors. As you can see, the last column is into W, and we sum up with the C values, where W is the sum of WC, WN, and WI, and C is the sum of CD, which is try catch, recursion, array declaration, compound conditional, and input output statement. So how basically input output statements is measured is by we assign a weight of 1 for each system output statements. So for example, if we take line number 4, so the size is 4, we assign a weight of 1 for int, and weight of 1 for x, and the equal operator, we assign a weight. And lastly, for the value of 10, we assign one weight. So basically the size is 4 and control structure is 1. So since there are no nesting levels, so it's 0. And inheritance level of statements, since it comes under the object class of complexity example, it is 1, which gives us the whole W value as 2. And since there are no C factors considered, we can calculate the complexity of the line number 4, which gives us 8, where we multiply 4 by 2. So likewise, we have measure the complexity of many lines of this code under these conditions. So moving to the existing tools versus proposed tools. So in existing tools, we have limited customization in IDE. We cannot change the rules according to the project. Web-based dashboards provides detailed feedback in the IDE and a centralized code quality management. So as you know, the famous ones are SonarLint and SonarQube. They do not measure the complexity, but they measure the inconsistencies of code, like to identify certain patterns, if there are any duplications of the code, and if there are unused parameters or variables. But CCMT particularly gives the attention to the measuring complexity of a code. So they have customizable rules. We can change the rules according to the project, a user-friendly interface, and we have considered 9 factors. So since it is in the initial phase, we have developed it only to support Java programming language, but in the future we be developing it to support other programming languages like Python and C# as well. And moving on to the discussion part, where the limitations of WCC metric are like inability to account for variable declaration, unable to distinguish method calls based on content, lack of consideration of input-output statements as well, they haven't considered it, and also difficulty in differentiating among various type of compound conditional statements as well. So we have addresses these limitations by incorporating with recursion, compound conditional statement, try catch, array declaration, and input output statements, and also an improved size measuring approach as well. So with that, we come into the conclusion. So the CCMT's adaptability and flexibility. So it's not only a tool for the present, but a catalyst for the future. So we can develop the tool to support other programming languages like Python, C#, and we can consider other factors as well, and also seamlessly integrate into cutting-edge domains like AI-driven software and development, and also contribute significantly to enhance of the software quality, maintainability, to structure the code, so which will be easy to maintain and understand. And also the CCMT can be a helpful companion for developers worldwide. So as I said earlier, they could measure the complexity of their code, minimize it, structure it very well, so which will be very easy to maintain and understand, and aligns with the evolution of software development process as well. And finally, it encourages the software engineering community to explore its possibilities further. So with that comes to the end of my presentation. So I hope you got a clear idea about what CCMT is, and thank you for listening.
Thank you for presentation. May I ask one simple question that majority of the code complexity measure tools, they were moving from a space of language specific to language agnostic, that they would work with any language. The formula
Yeah.
that you shared had one parameter about the lines of code, M, that you shared on your
Yeah.
presentation. So,
Yeah.
given that you have taken all the constructs like arrays and try catch blocks, everything, why do you
Yeah.
even want to figure in the total lines of code? It could be actually language agnostic if you drop that requirement of using the lines of code.
Yeah, so initially this equation was taken from the WCC metric and we improved the W2, okay, which is the factors we considered as recursion, array declaration, compound conditional, and try-catch block, including input-output statements. So this equation was already there. So without of calculating the whole complexity, you can calculate line by line and get the whole complexity under the code. So that's the whole point.
All right. Thank you.
Yeah, thank you very much.
I have one question for this work. What is your motivation for design and develop these tools?
Sorry, ma'am.
My question is, what is the motivation for your work?
Yeah, so motivation is since there's a need for a tool to measure like the complexity of a code. So sometimes it's like code refactoring. So there might be different ways, but so you need to structure the code and make it more simpler. So that's the reason we came up by adding more factors. We have considered 9 factors, so you can measure the complexity and minimize the inconsistencies of code and like so the developer can get a clear understanding of what kind of complexity the code is. So lower the complexity, so it's easy to maintain and easy to understand. So that is the whole point of CCMT.
Okay, thank you.
Yeah.
Thank you, sir. We'll be proceeding with our next presenter. I'd like to invite our next presenter, Suthiri, with their paper titled Imagery Data Impact Analysis in Machine Learning Algorithm Performance for Bushfire Detection Systems. Ma'am, if you're ready, then you can start with your presentation.
Thank you for the opportunity. I am Chaudhry Parthiban, a PhD student from Central Queensland University, Australia, being supervised by Dr. Fasad Sanati and Dr. Jahan Hashan from Central Queensland University, Australia. Today, I am going to present my study, Imagery Data Impact Analysis in Machine Learning Algorithm Performance for Bushfire Detection System. As you know, in recent years, bushfires have increased and leading to the urgent need for the advanced detection system. So this system can detect fire quickly and also more accurately. The impact of bushfire are huge, so we know that. And they have destroyed our landscapes, causing life-threatening conditions, threatening livelihoods, and also threatening the biodiversity. At the heart of this challenge, a rich source of information that holds huge potential for enhancing and the effectiveness of the bushfire detection system. So by using the power of machine learning algorithm, we can detect and respond to fire incidents more accurately and quickly. Anyhow, the effectiveness of machine learning and also the deep learning algorithm in this context is tied to the quality, diversity, and the granularity of the imagery data. So our research aims to conduct a critical analysis of how different type of imagery data affect the machine learning and deep learning algorithm used to the bushfire detection task. So nowadays, drone-based bushfire management system have becoming more popular. So this is the background scenario behind the drone-based bushfire management system. Let's see how it's work. So unmanned aerial vehicles, also known as drones. These vehicles are equipped with the advanced sensors and imaging devices. So these drones can navigate through the skies in the fire areas. So while the drone fly over the landscape, they can capture imagery data in real time, scanning for signs of fire activity. So this data, the collected data, then transmitted to the ground stations or cloud-based platforms for further analysis. But here's where it gets interesting. The quality and characteristic of the collected imagery data are most important to the system performance. So based on the background, drone-based bushfire detection background, our aim of this study is to identify influential factors that are related to the quality and quantity of the data set used in the imagery analysis for bushfire detection. And also, we aim to recommend effective algorithm for the improved accuracy of bushfire detection. So for our study, we have prepared the data set ourselves. To prepare the data set, we gathered images from reputable sources, including Google, Kaggle, and the Mendeley, ensuring a wide variety of landscape and the fire scenarios. To standardize our data set and simulate the real-world conditions, we applied the image processing techniques such as blurring and the smoothing techniques. So this image processing technique helped us to mimic the challenges, real-world challenges such as smoke, haze, or rain to make the real-world scenario. So each collected image was manually labeled into 3 classes: fire, normal fire, and also no fire. To facilitate the analysis, the algorithm analysis, we divided our images into 6 data sets, data set 1 to 3. So these data sets are varied in image quality, including clear, unclear, and the combination of both clear and unclear images. Similarly, the data set 4 to 6, this is varied in quantity of images to allow to explore the influence of quantity of images in the bushfire detection task. In our study, we employed 6 algorithms for bushfire detection task. We chose 3 CNN algorithm, BGG16, BGG19, and ResNet50. And also we chose 3 non-CNN algorithm, support vector machine, random forest, and logistic regression. So the CNN algorithm, these 3 selected CNN algorithm underwent training for 50 epochs using all the prepared 6 data sets. Also, the non-CNN algorithm, these also trained and tested using the 6 data set with the evaluation metrics, including the accuracy, precision, recall, and the F1 score. The comprehensive evaluation allowed to assess the robustness and generalizability of each algorithm we have selected for the analysis. The result obtained from CNN and non-CNN algorithm with dataset 1 to 3 were analyzed to understand how the quantity of data influences the fire detection. Similarly, the results from dataset 4 to 6 were investigated to examine how the quantity of data influenced the detection capabilities. And also to provide the comprehensive recommendations about the algorithm, we analyzed the performance of all algorithms across all 6 data sets, considering the factors like data quality, quantity, and the robustness of the algorithm. So we have grouped the results into 3 experiments. Let's see the results we obtained from the experiments. In experiment 1, we aim to assess the influence of data quality on forest fire detection using the both selected CNN and the non-CNN algorithm. The performance of CNN algorithm was significantly influenced by the quality of images. The higher quality image led to the higher training and validation accuracy. This result indicating better learning and generalization capabilities of this CNN algorithm. And the algorithm trained on the combination of clear and unclear images showed better generalization to the real world scenarios compared to the data set which only having clear or unclear images. So like in non-CNN algorithm, this exhibit the robust performance across all three data set regardless of the image quality. And these algorithms achieved high validation accuracy, precision, recall, and the F1 score values. This indicating their effectiveness in classifying forest fire instances in the scenario. And the results from the experiment 1 underscore the need for careful consideration of data quality when developing and deploying the bushfire detection system. And in experiment 2, we aim to evaluate the influence of data set size on forest fire detection using the same CNN and non-CNN algorithm. In the CNN algorithm, across all data set, training accuracy consistently exceeded the validation accuracy. This suggesting the potential overfitting issue on the data set we have chosen. The data set size increased, training accuracy tended to decrease slightly, while the validation accuracy remains stable or increased slightly. This result indicating the improved generalization of that algorithm. From the non-CNN algorithm, this achieved high validation accuracy across all data sets. These algorithms demonstrate the robust performance with consistent validation accuracy across different data set sizes. So the result we obtained from the experiment 2, it is revealed the impact of data set size, the quantity of the data size on the algorithm performance for the bushfire detection task. In experiment 3, we focused on comparing the performance of the selected machine learning, non-CNN algorithm with the CNN, that is deep learning architectures across varying image quality and quantity. In the non-CNN algorithm, it consistently demonstrates the robustness to varying the image qualities and maintaining the high performance across all data set we used. And these algorithms were well suited for handling different types of data. Also, these algorithms are faster to train and predict compared to the deep learning architectures. And these algorithms are efficient for the task with limited computational resources. When it comes to the deep learning algorithm, these algorithms achieved high accuracy on the clear images, but there may be a chance for overfitting issue when we are using the smaller data sets. And according to the result, the deep learning algorithm generally require the larger amounts of data to prevent from the overfitting issue, while the traditional like SVM, RF, LR algorithm demonstrate the competitive performance with
Excuse me,
smaller.
ma'am. I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Oh, sorry. Yeah, I'll finish it. So according to the result, the choice of the algorithm depends on the factors such as data set size, computational resources, interpretability, and the trade-off between complexity and the quantity of data. In conclusion, the higher quality images enhance the algorithm accuracy, and it is very important to balance the balancing the training and validation accuracy. This is important to prevent from the overfitting issue. And The machine learning algorithms are suitable for smaller data sets, and deep learning algorithms need larger data set to prevent from the overfitting issue. And the choice of algorithm depends on the factors: data set size, the computational resource, and the complexity of the problem. Thank you for listening. Do you have any questions?
Thanks for the presentation. Can you just let me know what is the parameter on which you decide that this data quality is good or not? I mean, resolution is one that I understand of the images, but most of the deep learning models are going to reduce the image to a standardized size to make sure that it is compatible with or computations complexity reduced.
Yeah. Actually, we are not reducing the resolution. So we are using the same resolution in the models, but the quality means we are applying the image processing techniques to smoothing and improving the quality. So we are applying the image processing techniques to improve the quality of image.
Okay.
Ma'am Narumol, would you like to ask any question? It might be possible she might have a technical issue. We'll be proceeding on with the next presenter for this session. I'd like to invite paper presenter Karthik here to present the paper titled NLP-based AI-driven resume screening solution for efficient candidate selection. So you may start your presentation.
Yes.
Yeah.
All right. Hi, team. So, so I'll be presenting on behalf of Karthik today.
Sure.
So, yeah. So I'll be presenting the NLP-based AI-driven resume shortlisting, for efficient candidate selection. So this is the topic title that we have. So what is the objective of this? The project is like we intend to automate the hiring process. So in our organization, we used to get hundreds of profiles for a single opening. Right? So we want to find a solution to automate the hiring process. We need to rank order the resumes for each and every job description that we have. Right? So we wanted to bring this approach and solve in the method of NLP and deep learning techniques. So how can we shortlist these resumes in a smarter way? So the problem statement is that in an official career page, we have to select various different hard-coded informations. Seldom the recruiters look into or they're interested into various different the parameters that you look into. So there are some customized parameters that each and every project managers look into. Right? So we do not have to look at it as a whole. So we are going to look at specific skills and criterias whether the candidate will be suitable for the project or the team or not. So what happens, behind the screen? It's not only the HR who's getting involved in this hiring process. The hiring managers, the project, the technical managers, get into this hiring. There is a lot of time spent on, the hiring, the shortlisting the profiles, scrutinizing each and every, resumes, and this is, very cumbersome process. So we wanted to bring up an, innovative solution using NLP here. So what is the proposed solution? What did our solution do in order to, to reduce the, time consumption of the project managers and various different technical stakeholders here? So we wanted to rank order the resumes or rank order the candidates' profiles on the probability values with respective JDs. Right? So it's not like one size fits all. So we have a job description and there are various different resumes. So what is that resume that fits in job description? And we want to rank order the resumes for the job description that we have. So what is the key feature of our solution? So I'm going to use an entity information extraction technique that's relevant for my own need. Right? So for example, I'm going to work in a project which is full of NLP project, or if it's an an computer vision project. So what is that skills that it is required for me? Right? So I'm going to train my own model from which from an unstructured and wide ranging formats, from the resume to rank order the applications using the content based recommendation by using the vector space model and similarity check between the job description and the resume. This is the key feature of our solution. So how is it unique from the existing solution? So the existing solution goes like this. So the recruiter has the keyword, the key value pairs or in dictionary that's maintained or kind of a lookup table. They look for an hard score, the keyword based, they get into the keywords of the resume. If that keyword is present, so ultimately they pass it to the L1, the hiring team. Right? So seldom it matches, and we don't get the right candidates, and we miss various different potential candidates. Right? So this is how our solution is unique from the existing solution. So this is the solution architecture that we have done. Right? So I'm going to get the candidate resumes in various different formats, and I'm going to do the entity classification. So what's an entity classification? I'm going to take the name, the occupation, the email ID, the LinkedIn, the various different primary skills, secondary skills. I'm going to do the entity classification. So I'm going to do the tokenization, feature tagging, and I'm going to get and resume in a summarized format. Once I get the resume in a summarized format, I am going to vectorize the resume. So there are various different vectorization techniques. So we have used in TF-IDF vectorizer. So we can use various different vectorizers. So, and the similar process goes with the job description as well. So I'm going to do the tokenization, and I'm going to do the job description in summarized format, and I'm also going to vectorize the job description. So, and I'm going to have a cosine similarity match between the vectorized the candidate's resume and the job description. So on basis of this, I'm going to rank order the candidates for each and every job description. So this is the solution architecture. So as a whole. So do we have any questions here, or shall I move on? Okay. All right. So how did we get the training data? So we have collected over 200 plus resumes, for the preparation of the training data. So the data preparation goes like this. I'm going to read all the resumes in an iterator format. So it's in a PDF and in .doc formats. And I'm going to do the data pre-processing techniques like removing the punctuation, the special characters, stop words, and I convert it to the root words. I convert it to the stem or the lemma of the word. And wherever there is an extra space or lines, so it's the basic deep pre-processing that I've done for the resumes. And I'm going to pass it to the NER pipeline. So the data preparation with labels. So this training data is hand annotated. So there are various different annotators available. So we have used in Prodigy Annotator. So I'm going to annotate for all the the resumes that we have considered for the training. I'm going to annotate which is an email ID, which is a name, which are the skills, and what are the previous organizations that the candidate has worked. So it's a hand annotated. I mean, using the tools, and I'm converting the data to a .spacey format since I've used an spacey library. So the spacey library requires the data for training to be in a .spacey format. So, and I've taken the config file, I've altered the hyperparameters, and I've trained the model. All right. So going forward, conversion of data into a spacey model. So the spacey 3.0 is the library that we have used. It's a binary, it's a binary format which has a serializing doc bin format. So once the data has been cleaned and it's all saved, I'm going to convert it to a spacey format. .spacey is the format. So I'm going to convert it. So these are the different entities that we have picked, right? So now it has been extended, but the objective, name, designation, contact number. So these are the different entities that we have annotated using the Prodigy tool, right? For the 100 plus resumes that we have considered for the model training. All right. So this is how the training data was. So from which character to which character? Divanshu Bajpai. This is the name. And 68 to 99. This is the location. So from this character to this character, it's an email address. So so this has been done automatically using the various different annotators, right? So behind the screen, this is how the training data will be. Okay, now let's get into training an NER model. So what's an NER model? Named Entity Recognition Model. So in Spacey, the model has been trained and updated the weights by computing the gradient of the loss. I'm going to use a backpropagation algorithm. So I'll explain you in detail. So what is that steps that we have encountered? I'll also have the next architecture, I'll show you that. So the training data, whatever we have taken the text label, we have found the gradients and the model. So using the backpropagation, so we train it in various different epochs and we get the updated model. So if you ask me what is the architecture, what's behind the screen, architecture in the sense, what's the model architecture? So we have taken the input text, the raw text. So we have the embedding layer. So, as we know, the embedding, we are going to take the high dimensional embedding space and, capture the semantic representations. And the convolution layers are being used, and recurrent layers and linear layers. And at last, we are going to represent the predicted named entities for each and every token in the input text. So this is the model architecture that we have used for this model, for this project. Going forward, so this is the success criteria we have called forward. So we wanted an goal of precision of 95%, recall of 95%, ultimately F1 score of 95%. So we have done 3 different experiments. So we have done multiple experiments. I have mentioned 3 experiments here. So initially I started with 50 resumes with various different parameters. I've used an Adam as an optimizer. So, and then we could see that the model had a precision of 75%, recall of 55%, and overall the F1 score was 63.9%. So this is for the various iterations that we have for the various epochs, to be technical. So, and we can also see for each and every entity, what was the precision, recall, and F1 score. So the model was not able to identify various different locations and the degree. So these were some places where the F1 score were less, and the name it was able to identify it fair and good. Second experiment, so I've taken 100 different resumes with an Adam as an optimizer. And going forward, we had seen and precision to be 96%, recall to be 76%, F1 score overall to be 85%. Right? So with fewer changes in the hyperparameters. So ultimately, one change from experiment 1 to 2 is the data set being increased, right? The training data is being increased from 50 to 100. And the third one, so we have taken, over 100 plus, I think over 190, it's close to 200 resumes that we have taken for the model training. And the Adam as an optimizer, and not much changes in the hyperparameters. So we have fixed the hyperparameter. And so we have reached a precision of 98%, recall of 98%, F1 score of 98%. So it was able to identify the name accurately, the designation close to accurate, 98%. So the location still it was, it was 93%. So ultimately, so as the data set increased, with small changes in the hyperparameters, so we were able to reach the goal of 95% F1 score. So how did the entity identification be? Right. So for various different resumes, so we can see the name. Yes.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Okay. Yeah. So the entity identification was this, like what is the name, various different entities in a resume. So this is how the extracted entities were. So let me quickly go to the final model. So how was it? Right. So the final model and output. So we can see for different resumes, if it is a Python developer, so which were the candidates and what is the similarity score? So, and what are the different candidate names and what is the similarity score? Right. As a hiring manager, the HR, if they have the model as, as a prerequisite, so they can order these candidates and they can schedule the interviews. Right. So the final operating model was there. So, and yeah, so this is the proposed UI. So I can upload various different resumes and the job description. So I get the rank order for each and every job description and the resumes that we have. So, and then I can, I have the option to download it as an Excel. And the various challenges that I faced was if there is a Python that's present in a primary skill and then secondary skill. So there is some challenges faced in understanding what is in primary and what is in secondary. So it's giving an equal importances. So these are, a few challenges faced, and when there is some space, I need to give the exact start and the end location where this tools, sometimes messes around. I'll have to do some manual work here. So the training data is the challenge here, right? So let me take to here, and I'll call it a day. So I'll open the room for any questions.
So Amazon actually tried to do the same, what you are currently doing. They had a resume screening process which went into big trouble because it was biased, inherently biased, and people came out with that's why the process. So largely, what do you think can be the sources for bias in your data set?
Okay, thanks for that, and that's a fantastic question. Bringing in responsibly is the the primary criteria these days. And when the data set has been biased, say for example, I'm going to take let's take the gender as a bias here. So I'm going to in the training data, if I'm going to take all 90% male resumes and 20% 10% of female resumes, obviously the data set is biased. So how I'm going to tackle it, it's with the quality of the training data that I'm going to consider it, right? So if so there's an a project that's for the internal within our team, right? So our team or in our own practice, the data practice that we have. So the bias can be tackled. So if I'm going to have an quality data, it's all about the training data and the right resumes that I'm going to pick for the training model. So that's the only way that I can bring in
Apparently, all your results are male candidates.
If it's 100% male candidates, so obviously there's going to be a bias and the similarity could go down.
Hi.
The rank
Thank you.
Yes.
Um, how can you got this input data for your work?
I'm sorry, I just lost it.
How can you got this data for your work? Your data?
Okay.
Yeah.
My training data, you mean how did I collect the training data? So it's the training data that we had it in our organization and our internal repo. So all the training data that we have within the organization. So taken that as the training data. So all the resumes that within the organization. So for whatever the resumes that we have got it in practice. So yeah, so that's what we have taken.
Okay.
Thank you, sir. Thank you, ma'am. This was our last presenter for the day. This brings us to the end. I sincerely thank our authors for their excellent presentations and contribution this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 9th version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team of ICICT 2024. I would also like to thank our session chairs, Ma'am Naramul Sherman, for chairing this session. A token on behalf of Team ICICT and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am. I'd also like to thank our session chair, Professor Sachin Gupta, for chairing the session. A token of appreciation towards you, sir.
Thank you so much.
Thank you, sir. Before we end the meeting, I'd like to request everyone to turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone.